Hi all and welcome to Beyond Strength by Strenx. And actually, I'm a bit overwhelmed how much you have been interested of our videos, so thank you so much. I noticed that we have reached out at least one audience group, so I need to say hi to all our structural engineers. And as you always are, you are precise and accurate, and I'm happy about it. But actually, I have a treat for you. I will introduce my go-to person, our structural engineer, and yes, we are going to deep dive in.
Hello everyone, my name is Nima. I'm the structural engineer at SSAB, and today we talk about similarities and differences between mild steel and high-strength steel.
In the last episode, we talked about yield strength, a little bit simplified way, but I want to go deeper in. Okay, let's see what do those curves mean.
If we would have put those samples into a tensile test machine and with a little bit of a mathematical work on the outcome of the machine, we would get to something called true stress, true strain curves. Engineers use these true stress, true strain curves as a representation of how material behaves under stress. For mild steel, these curves, in a very simple form, can be drawn as something like this. Here I have true stress and here I have true strain. Now, the curve at the beginning rises up as a linear line with a slope of 210 gigapascal. Now, if we keep stretching, at some point the curve deviates from linearity, and this point is a very important point for all engineers, called yield stress. As long as the stress is below the yield, the material is behaving elastically, meaning that if we offload the sample at any stage below the yield stress, it will completely go back to its original form. This is why this zone is called elastic zone. However, in the contrary to elastic zone, if we keep stretching beyond the yield stress, the material will be plastically deformed, meaning that the deformation is permanent. It will never ever comes back to its original form. This is why this zone is called plastic zone. For Strenx 700, the curve will look something like this. And mild steel. The difference is that the yield of a Strenx 700 is much higher than mild steel, meaning that it can tolerate more stresses before being plastically deformed. It's simply a stronger steel. The similarity is that the slope of the curve in the elastic zone is exactly the same for both curves. It's actually exactly the same for all sorts of steel all around the world.
And now you might wonder how we are going to utilize this in the real world. Well, you will see it in next episode.